Hello everyone and welcome back at CodingBulls. Today we will continue our beginner C++ tutorial series and we will focus on nested loops and two-dimensional arrays and vectors. Let's go ahead of our codebox. We will continue from where we left off. We go ahead and delete these old Fibonacci codes. If you want, you can create a new file instead, the same way I showed you in the first video. Let's define maximum size 2000. The way you create a two-dimensional array is you first specify the type, let's say integers, then you give a name, then you will give maximum size, and then you will give another maximum size. So this is a two-dimensional array. You can create a three-dimensional array the same way by adding a third type. In vectors, you will need to type vector, the same way as in the regular vector, but in the type here, you will type another vector. And the second vector will have integers as well. So now you have a two-dimensional array and a two-dimensional vector. As you can see, the array size is already fixed, but the vector is empty in the beginning and doesn't contain anything. So we will take the input from the user. Now we will create a nested loop. So we create a for loop, and then inside of this for loop, we will create another for loop. So if we want to take all the two-dimensional arrays input from the user system, then we can create two for loops. When we are done with this for loop, we will reach the end of this for loop, and we will go ahead and repeat this process n times. So we actually repeat this inside for loop n times m times m times, where our e variable will go from 0 to n, and the j variable will go from 0 to n, never reaching n and m, so they will go until n minus 1 and until n minus 1. And the order it will go will be, first, I will be always 0. So when we entered loop for the first time, we set I to 0. And the i's value won't change here until we are done with this loop. So here we have an I value, and this won't change until here. So we go through this inside loop, then we reach the end of this loop, so we repeat it unless I is greater or equal to 1. So we repeat this again, and we have another I value. So first I will be always 0, and j will go through 0 to m. So let's say n is 3 and m is 3 as well. Then we will have the following paths. I and j paths will go in the following order: 0, 0, 0, 1, 0, 2. Then we will reach the end of this loop because j will be equal to m. So we go out of this loop, then enter this loop again. So I will be 1 this time, and j will be 0 again. Then we will have 1, 1, 1, 2, and then we reach the end of this loop again, and we go here, where I will be 2, and j will be 0. Then 2, 1, then 2, 2. And after that, we reach the end of this loop, and we will reach the end of this loop too. So as you can see, this is the order. And what you need to be careful about is in nested loops, it's really easy to exceed the time limit. This is something that I haven't talked about, so I will teach you. So the time limit will vary based on what type of coding you are doing. In most competitive programming, the time limit is usually somewhere between 1 and 3 seconds. But important to remember for everyone is 1 second of execution time is roughly equal about 10 to the power of 7 operations. meaning that if we count the maximum times something will result in an operation, and here we can have anything. Let's say that we just create an integer, and then we will take it from an input, or we make any kind of operation here that can be assigning a value, calling a function, anything. So we count the maximum number of times it can happen, which is n times m. So if n and m are maximum 1000, that means in this example 1000 times 1000, which is equals 10 to the power of 6, or roughly about 0.1 second if the values are maximum. So you will need to pay attention if n and m are too high. So if we have a nested loop where we go through date 100,000 steps, this is also a very common constant in programming languages where some value is maximum 100,000. In these type examples, 100,000, which is equal to the 10 to the power of 5. So if the nested loop has 100,000 steps, then we need to multiply it by itself because we have nested loop, which is equals to 10 to the power of 10, which is really high and would take about divided by 10 to the power of second for 1 second, 10 to the power of 3 seconds, which would be 1000 seconds. So as you can see, we need to be careful because we can run out of time in it really easily. Even if you are not doing competitive programming, you normally don't want to wait 1000 seconds for a program to stop executing. So be careful with this. In this example, n and m can be 1000, so it's fine to use a nested loop. Let's go ahead and see how we can assign the values for the vector v and the array a. So for the array a, we can actually go ahead and take the input without any other values. So we just take the input, we refer to it. First dimension is I, and the second dimension is j. So we can go ahead and take the input like that. If, however, we have a vector, then you need to have a value that you take from the input, and then we will go ahead and remove or comment this out, and then you can take the vectors if dimension and then push back that value. The problem with this is this vector that contains the vectors is empty in the beginning, and this will result in an error because we will try to push back to a non-existing element, because this outside vector doesn't have any element, so VE doesn't exist. To avoid this, we need to resize the outside vector, this one, to n, because it contains n elements. Now here we can just push back to the vector. Another way to do this is to also, in the first loop, resize m. So now we have a vector of a size of n, and each of these will have a size of m. So here we can actually go ahead and assign the value like we would do in an array. And I will assign to the value of the array as well. So normally you don't want to have an array and vector with the same values. You would want to choose one of them. I will go ahead and continue this example with both, so you can understand the difference and you can choose according to the problem you are facing. So now we have the vector and the array filled up with numbers. Now we can go ahead and do any operations with that. Let's say that we want to select the minimum value, and we also want to tell where it is. So for this, we will have a position that we will save the x and y coordinates too. And that's where we will have the minimum value that we want to update every time we find a new element with a lower value. So these variables doesn't have a default value yet because they are inside of the main function. So let's go ahead and give a default value x and y. Let's be 0, and we need a default value for minimum value too. I come back for this later. There are two ways to do this properly. So first we will write our nested loops again. So we go through the array or the vector, whichever you like to use. And in most cases they will work really similarly, because you will refer to each element the same way. So I will just use one of them, the vector in this example, but you can do this the same way with the array. So if this current value is less than the minimum value, then we will need to get a new minimum value and save the position that this is now currently the minimum value. So we will save this position and we will go ahead and continue to loop. So every time we found an element less than the minimum value, we will swipe it. It's an interesting question what happens if we have the same minimum value that we already had. In this case, you need to take a look at the problem. What does it require? Does it require you to list all of the minimum values? Does it require to list any of them, or the minimum or the maximum? In this example, we will just delete this code. We won't do anything with it if it's a minimum value. In this example, we just want to find any of the minimum values position. And in the end, you can just output minimum value is, and then minimum value, and then we will output minimum position is at position x, position y. Lots of times we index from 0 in the code, but the problem statement requires you to index from 1. To solve this problem, we will also make an example if the problem statement indexes from 1. So we index from 0 and the problem statement index from 1, so we will add 1 when we output the value. So it will be the correct format. Now one more question: what does the minimum value starts with? Because we need to assign a value to it in the beginning. So one of the ways to do this is to give a maximum value of it, which all the other elements will be less than. So when we enter the first time, it will definitely change the value. The way we can do this is just simply type int max. This is the maximum value of an integer, and we can just assign this value to the minimum value. Another way to do this is to read the problem statement and give a value higher than the maximum possible value. If the maximum possible value is higher than int max, then instead of integers, you will need to use a long integer. In this example, let's just use int max. So now cool. Let's go ahead and run our code. As you can see, we got an error. We forgot to give a type name and so we will just do it here. Now we return it again. Then we will give an input. So let's say that we have a 3 times 3 array. Now we will input the elements. Let's have 5, 3, 0, and I will do a line break so you can see the input better. For the input, it doesn't matter if you put a line break or a space between them. It will be alright both ways. So we will have 100, 2, -1, -10, 1, and 9. Now if you press enter, you can see that the minimum value is -10. The minimum position is on the 3rd row and the 1st column. So this program works correctly, and we solve the problem. So another way to deal with this minimum value default value is that instead of the int max, you say that it should be the v0, 0. Because in the beginning we set the position to 0, 0, and we will say that that's a minimum value. If we don't find a value less than that, then it's true. If there is a value less than that, then we will find it in these two for loops. Therefore, this is also a correct solution, and we can go ahead and run it. I will just show you a smaller 2x2 example this time. So let's say that now this one will be the smallest, and you can see that the minimum value is 100, position 1. Hopefully you enjoyed today's video. If you did, make sure to like and subscribe. And in the next video, we will take a look at a more complicated example where you will need to use all 4 videos so far from beginners C++ tutorial series videos.